Okay, so far what we did is we took the main structure away from its main supports and found the reactions of the supports. So that's the first thing you do for truss problems, always. Okay, so now, there are two different ways to solve truss problems. One is called the method of joints. And one is called the method of sections. You're going to see that there's a similarity between both of them, so I'll show you the similarity as we move on. But for this problem, since they're asking us to find the forces in each of the members, or really I could have said in all the members, I'm going to do it by method of joints. So, method of joints. So what I want you to do right now is get comfortable with the method of joints, and then I'll talk to you about how it differs from sections, and then we'll move on to a problem where we just do a section. But you'll see that they're very similar. So let's take a look at some of these joints. And I erased my fingers, so I'm going to reconnect them, erase the lines of my fingers. So which of the joints? You probably have imagined that there are 4 joints here, A, B, C, and D. At joint A, I have 2 external forces here, AX and AY. And let me just put down that this is what we called N and this is what we called AY. And then I already had AX written. So I have 2 external forces here. Right now, this member AB and AD are intact. So the force that's being transmitted inside them is considered an internal force. It's not until I break it, that I separate them, that force becomes external. So let's draw member A. So member A has 448 pounds going up. And I'm still drawing it the same way it was. I have a negative 1,200 pounds going to the right, which really means it's going to the left. And then, in addition to that, AB, if this is a 2-force member, the load that this member is being subjected to is going along that axis. So I'm going to put this in a different color. So this is really the load for AB, and this is the load for AD. And let's put 3, 4, and we have to put our little axes, X, Y. Does this make sense on what we're doing right now? This is exactly what we did for the frame problem. When there was a problem where there was a member that was a 2-force member, we put the load going right through the member itself. And I drew it away. Remember, we drew it away before too. I'm drawing it away. When I draw it away, am I drawing it in tension or in compression? Remember, when you draw something away, it's tension. If you draw it towards, it's compression. So now this joint A has 4 forces on it. What's the adjective that describes these 4 forces? Concurrent, right? Concurrent forces are forces that all act on the same point. Does point A, can it move linearly? Yes. Can it rotate? No, because all the forces are acting on that point. So at most you have how many equations do you have? How many equations can you establish from this, just analyzing this one joint? Only 2 equations. Some of the forces in the X and some of the forces in the Y. So, which equation do you want to do first? Some of the forces in the X or some of the forces in Y? Well, if you do some of the forces in the X, you're going to get 2 unknowns, so don't do that one. But if you do some of the forces in the Y, you're only going to have the part of AB. So let's do that one first. Sum of the forces in the Y equal, this is a 3, 4, 5 triangle, right? And the Y component is 4/5 of AB plus 448 equals 0, and in the end, AB equals 5/4 of 448. I'm gonna go get my calculator. Put it on pause.
Okay.